Hi guys, today we'll be going over the binomial theorem. The binomial theorem is an alternative to expanding binomial expressions. Basically, it is a shorter way of foiling large numbers. Now, we'll be focusing on the binomial probability. Let's go straight to the binomial probability formula. The formula is P times K successes in n trials equals n chooses K times P to the power of K times Q to the power of n minus K. Now what does this mean? N equals the number of trials, K equals the number of successes, n minus K equals the number of failures, P equals the probability of success in one trial, and Q equals the probability of failure in one trial. Now here are some basic rules that you have to keep in mind when doing the binomial probability. Each trial can result in just two possible outcomes. We call one of these outcomes success and the other a failure. The probability of success, denoted by P, is the same on every trial. The trials are independent. The outcome on one trial does not affect the outcomes in other trials. As an example, imagine that you have a coin. Now a coin has two sides, so there is a 50% chance of getting heads and a 50% chance of getting tails. If you have as a question, if you flip a coin 10 times, what is the probability of getting heads 3 times? Now let's go back to our formula. P times K successes in n trials equals n chooses K times P to the power of K times Q to the power of n minus K. Now if we plug in the numbers, it will look something like this. 0.5 times 3 successes in 10 trials equals 10 chooses 3 times 0.5 to the third power times 0.5 to the seventh power. Now these numbers, what do they mean? Remember, n equals the number of trials. So you're flipping the coin 10 times. That means that there's 10 trials. K equals the number of successes. Now, you get heads 3 times. That is the number of successes. N minus K equals the number of failures. So the times that you get tails. P equals the probability of success in one trial, and Q equals the probability of failure in one trial. Since there's only two possible outcomes, either heads or tails, there's a 0.5 or 50% chance that you will succeed or that you will fail. Now, what does 10 chooses 3 mean? This is a binomial coefficient. A binomial coefficient are the number of ways of picking k unordered outcomes with n possibilities. The formula for the 10 chooses 3 goes a little bit like this. N factorial divided by r factorial times n minus r factorial. Now, what is this exclamation mark? This exclamation mark is a factorial. A factorial basically is when you have a number and you put it to the factorial at 5 factorial, it is a number multiplied by all the numbers that go before it. So it would be like 5 times 4 times 3 times 2 times 1. If it were 10 factorial, it would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and so forth. So we have 10 chooses 3, which uses the formula. Now, how, factorials, you don't want to do, like, if you want to find a quick way, you can use your calculator to do this. Just go on math to probability, and then number 4 is a factorial. You plug in the number, press enter, and voila, you get your answer. This is an easier way or a quicker way instead of multiplying 10 when you have like really big numbers, like for example, I don't know, 50, where it has to be like 50 times 4 times 49 times 48. You can just do this in the calculator, which is really quick. So now that we know what a factorial is, let's go back to the problem. 10 factorial divided by 3 factorial times 10 minus 3 factorial. This will equal 3,628,800 divided by 6 times 5,040. This equals 3,628,800 divided by 30,240. which in turn equals 120. Now, if we put this back in the formula which we started with, it would be 120 times 0.5 to the third power times 0.5 to the seventh power. This will give us the probability that we were asking for in the last question. So we have a 0.12% chance of getting heads 3 times if we flip a coin 10 times. So we finished the problem, and here are some of the things that you have to always remember and take into account when doing binomial probabilities. Remember that each trial can result in just 2 possible outcomes. We call one of these outcomes a success and the other a failure. The probability of success, denoted by P, is the same on every trial. Also, the trials are independent. The outcome on one trial does not affect the outcome on other trials. Don't forget the formula. P times K successes in N trials equals N chooses K times P to the power of K times Q to the power of N minus K. Thank you for watching, and I hope you learned something. Goodbye.